Thanks for joining this Leapcast. Today we're going to have a look at Cisco UCS Manager, LAN and networking. Just a little about the Leap Center before we start. LEAP stands for Learn, Experience, Architect and Plan, and it's our state-of-the-art Cisco Data Center UCS Demonstration Center based out in Brussels. We've got full remote access to the system. This is the equipment that we have in there. You'll see we've got IBM HP servers to do comparative tests, EMC and NetApp storage, MDS 9148, Cisco UCS C and B series servers, as well as Nexus 7000 and 5000. These are some of the demos that we've got available to deliver to your customers, along with we've got the ability to create bespoke or more personalized demonstrations if we require. And with that, we'll get straight on into today's Leapcast, and we're going to have a look at LAN and networking. So this is UCS Manager. This is our managing our B series servers over in Brussels at the moment. And we're going to have a look at QoS and how we can build virtual network interface cards. So here we've got the QoS system class. This is a global setting for the entire platform, so any changes we make here will affect all the various QoS policies. So you see here we've got priority traffic classes defined from Platinum all the way down to best efforts, and then fiber channel. Here we decide whether they're enabled or not. Here we can enter their corresponding QoS values. Here whether we're going to allow packet drop, so you'll see on our Platinum traffic and fiber channel traffic we're not going to permit any traffic drop. They're our premium traffics. We can also set the weights here, and you'll see we've got the corresponding percentages of scheduling time bandwidth that will be allowed for them. I'll just make a change to this bronze traffic class now, just for an example, and I'm going to set that to 6, same as silver. And if I just choose to save the changes, you'll see that updates, and the weights have actually changed. So I'll do that again. I'm going to change that back down to 5. Choose Save Changes, and you'll see the weights change. Here we've got MTU sizes, whether we're normal sort of 1500 byte size frames, or whether we're going to allow fiber channel size frames 2500 bytes. And here we've got a link for the checkbox, for multicast optimization. Just wanted to have a quick look at the pin groups. So out of the chassis we've got multiple links up to the fabric interconnects, and if we so desire we can create pin groups, and later we'll see where we can apply those pin groups, and that will then determine that traffic will only travel on a particular physical interface. And this I've seen used where there's a requirement, say for like a web server that's doing credit card processing, and there's a legislative requirement that the traffic travels on separate physical interfaces. So we could have one blade running the front-end web server, pin all the traffic on one link. Then we've got the back-end database server running on another blade in the system that's got all this sort of credit card and the various processing information connections out to Amex and MasterCard, etc. And we can then pin that traffic over another link. So that allows us to then ensure and guarantee that there's physical segregation of traffics. VLANs. So here I've got all the sort of VLANs that we use in the Leap Center defined here. You'll see we've got some DHCP ranges, host ranges for sort of fixed Leap management, VMware Service Console, vMotion, etc. All all the VLAN definitions are done here, and we can just do create VLAN, put in the name, say whether it's common A and B or both fabrics configured differently, and then we can assign different VLANs, give it a VLAN ID, etc. We even got the ability to create private VLANs as well. Quick look at flow control policies down here. So we've got a default and a flow control on policy, so you'll see the receive and send is off here. You just take a closer look in there. You see on my flow control on policy, we've got that switched to on, and we apply these on the uplinks. I'm using a port channel, and we've got the two physical interfaces that make up that port channel for the northbound LAN connectivity. And here I'm using default at the moment. I could select that to flow control on. I'm not going to. We're not actually using it on the system here. And then if we go down into the sub-organization that I've created specifically for these leapcasts, we've got network control policies. So we just take a closer look at them. The main thing, excuse me, here is CDP enabled or disabled, and action on an uplink failure should we want to send a warning or perform a link down action. But as we're going to have redundant paths out of the system, we're going to automatically reroute all the traffic around available links should some of the uplinks fail. Threshold policies. We can create a threshold policy just as an example. So we can take various counters. So let's have a look at Ethernet port error stats. We'll click next, and we'll add some counter values to that. So we'll choose bad CRC packets minimum delta. So we can choose informational. So if we get 5, we'll send an information warning. If we get 20, we'll say it's minor, and if we get 50, we'll say it's critical. We'll choose OK and finish. So now we've created a threshold policy for alarm propagation. So should we see those values that we set there, see this many CRC packets on a particular interface, will then start feeding alarms back up through the system. Vast amounts of alarms. I just wanted to give you an example. So now we're going to go and create some QoS policies. This is an example. It's not a design recommendation. I just wanted to come up with something that would give you a better understanding and appreciation. So I'm going to create a QoS policy, and I'm going to call this premium data traffic, and I'm going to give that platinum priority. I'm going to leave the burst rate and line rate the same. Host control will determine whether or not QoS values from hosts are rewritten or not. So if we choose none, all the traffic from the host that we eventually assign into this interface will stick with this platinum traffic, which will eventually get QoS 5, if you remember back to the global QoS policy. If we put full, that will then allow different QoS traffic values sent from a host to go and filter into the different queues. So there we've got one QoS policy created. I'm going to create another one called standard data. And for standard data, I'm going to give that bronze. Click OK. I'm going to create one for the motion traffic. And in this case, I'm just going to give that silver. And another one called service console, and in this case I'm going to give that gold. Like I say, this is not really a recommendation. It's just for the sake of this example. Now I've got my QoS policies created, and they're now associated with our quad system class. Let me just head back there. And there we go, platinum, gold, silver, bronze traffic types. So all the traffic will get those associated quad values. Now we're going to create our virtual network interface card templates, and I'm going to call this premium data. I'm going to enable failover, so traffic will initially go across Fabric A, and should there be a fault on Fabric A or upstream, traffic will automatically switch across to Fabric B. This is an adapter, we're not going to propagate that up, and for my premium data I want these particular VLANs to be accessible. I'm going to use my ESX MAC pool, and I'm going to apply my premium data quads policy. I'm going to have CDP off. I'm not going to use a ping group in this case, and I'm not going to bother with the stats threshold policies that I've created. Choose OK. I'm going to add another template called standard data. Again, we're going to enable failover. It is an adapter, and this time I'm going to allow a couple more of the. I'm going to allow my DHCP arrangers in there. Use my ESX MAC pool, standard data, CDP off, and we'll go there. And next, yeah, you guessed it, vMotion. And for vMotion, I had a vMotion VLAN. I'm not going to enable this as a native VLAN. I'm going to leave it as a tagged VLAN. Use my ESX MAC pool. Use my vMotion. I'm not going to worry about the rest for now. We've seen those. And finally, create my service console. And I had VMware service console there. Standard MAC pool. Service console quads policy. Click OK. There we go. So now we've got the virtual NIC templates created with the correct quads policy applied, and the access to the VLANs that I wish to give them.